Let's talk about the James Webb Space Telescope, or JWST, the most powerful space observatory ever built. It's the successor to Hubble, but it sees the universe in infrared, letting us peer through cosmic dust to witness the birth of stars and galaxies. Webb is a cosmic time machine, able to detect light from the first stars and galaxies formed after the Big Bang, over 13.5 billion years ago. Its giant golden mirror, made of 18 hexagonal segments, collects this ancient light. Webb was folded up to fit in a rocket, then unfurled a million miles from Earth. It doesn't just look at the distant past. It also studies exoplanets, icy moons, and mysterious objects in our own solar system. Its sensitivity is so high it could detect the heat of a bumblebee on the moon. Protected by a 5-layer sunshield the size of a tennis court, Webb stays incredibly cold, essential for seeing faint infrared signals. The JWST is a leap in our ability to understand the cosmos, a testament to human curiosity. Every so often it points its golden eye at something unexpected, something that changes everything. And recently, it turned its gaze to a truly rare visitor, a cosmic messenger from another star system. The story of 3I/Atlas begins here. Meet 3I/Atlas, an interstellar object, meaning it's not from our solar system. It's only the third confirmed interstellar visitor we've ever seen, after Oumuamua and 2I/Borisov. Atlas refers to the Hawaiian telescope system that first spotted it. When astronomers calculated its path, they saw a hyperbolic trajectory, proof it was just passing through, not bound to the sun. Imagine a cosmic tourist flung from another star system now racing through our neighborhood. 3I/Atlas is likely an interstellar comet, a chunk of ice, rock, and frozen gases. As it neared the sun, its ice is vaporized, forming a faint halo, a classic comet signature. But this is no ordinary comet. It's a piece of another world, a sample of the raw materials that build planets elsewhere in the galaxy. For the first time, we had the perfect tool, JWST, ready to study it in detail. This was a once-in-a-lifetime opportunity, a chance to analyze the chemistry of a visitor from another star, and the race to observe it had just begun. The world's most advanced telescope was about to make history. The countdown was on. 3I/Atlas began its journey in a distant star system, born in a swirling disk of gas and dust. It was ejected by gravitational chaos, flung into the interstellar void, never to return home. For millions of years, it drifted through the cold, dark expanse between stars, bombarded by cosmic rays, preserving the chemistry of its birth. Then, by sheer chance, its path intersected with our solar system. The odds are staggering, a tiny object crossing the vast emptiness to pass close enough for us to see. It's like a grain of sand from a distant beach washing up on our own shore. Its encounter with our sun is just a brief stop in a journey spanning eons. The discovery of 3I/Atlas after Oumuamua and Borisov hints that these cosmic nomads may be more common than we thought. The galaxy is full of wanderers, each carrying secrets from distant worlds. And now, for a fleeting moment, one had come within our reach. The stage was set for an unprecedented observation. The universe had delivered a message in a bottle. When 3I/Atlas was discovered, astronomers raced to observe it before it vanished forever. It was faint and distant. Earth-based telescopes could barely see it. Only JWST, with its infrared vision, could reveal its secrets. The telescope's team quickly approved a special observation, turning Webb's golden mirror toward this ghostly visitor. Time was short. 3I/Atlas was already speeding away. Webb's instruments, NIRSpec and MIRI, split the comet's faint light into a spectrum, a chemical fingerprint. The data streamed back, a clear, high-resolution spectrum of an object from another star system. For the first time, we had a detailed ingredient list for a comet born around another sun. The faint smudge seen from Earth became a treasure trove of information. This was a landmark achievement. Right tool, right place, right time. Humanity had just unlocked the chemistry of an interstellar visitor. The results would change our understanding of the cosmos, and the excitement was just beginning. Why all the excitement? 3I/Atlas is a direct sample from another solar system. We can't travel to other stars, but this object brought a piece of one to us. Studying it is our only way to analyze the raw materials that form planets elsewhere. With 3 interstellar objects found in less than a decade, it suggests our galaxy is full of these cosmic messengers. They might even carry water and organic molecules between star systems, raising the possibility of panspermia, the spread of life's building blocks across the galaxy. Each visitor is unique. Oumuamua was rocky, Borisov was comet-like, and now 3I/Atlas gives us a third data point. Are comets everywhere made of the same stuff, or is there wild diversity? Every new discovery helps us understand if our solar system is typical or unique. The thrill is in the unknown. Every photon Webb collected was a message never seen before. The data from 3I/Atlas will fuel research for years, pushing the boundaries of what we know. It's a cosmic message in a bottle, finally opened, and we're just beginning to read it. The data from JWST isn't just a pretty picture, it's a chemical blueprint. By analyzing the spectrum, scientists can identify molecules released as 3I/Atlas's ices turn to gas. The main goal: measure water and compare its fingerprint to Earth's oceans. Ratios of heavy water, carbon monoxide, methane, and ammonia reveal the environment where the comet formed. Comparing these to comets from our solar system shows the chemical diversity of planet-forming regions. Scientists are also searching for complex organic molecules, the building blocks of life. If found, it would suggest life's ingredients are common across the galaxy. Webb can even study the dust grains, tiny clues to the solid materials that build planets. By studying this alien dust, we glimpse the worlds that might orbit distant stars, all from a tiny visitor just passing through. How did JWST see what others couldn't? 3 reasons: location, size, and instruments. Webb sits a million miles from Earth at L2, where its sunshield blocks heat and light, keeping it ultra-cold. This cold is crucial. Only then can it detect faint infrared signals from distant, icy objects. Its giant mirror collects far more light than Hubble, making faint objects visible. Webb's spectrographs, NIRSpec and MIRI, split light into thousands of wavelengths, revealing each molecule's unique signature. This combination, cold, size, and technology, made Webb uniquely capable of studying 3I/Atlas. For a brief window, it captured the secrets of a visitor from another star. The result? A chemical fingerprint never before seen. Webb turned the unseeable into data and opened a new era of discovery. Webb's observation of 3I/Atlas is just the beginning. With new survey telescopes like the Vera Rubin Observatory, we'll soon find dozens of interstellar objects every year. The dream: send a spacecraft to intercept one, sampling its gas and dust up close. It's a huge challenge. These objects move fast and appear with little warning, but NASA and others are already studying rapid response missions. Imagine flying through a comet's coma, or even landing on its surface. Even without a mission, a growing catalog of interstellar objects will reveal patterns in their chemistry and origins. We might even trace some back to their parent star clusters. The study of these objects is becoming a systematic science, not just lucky discovery. 3I/Atlas and JOST have opened the door. What lies beyond is a galaxy of possibilities, and we're just getting started. Why does this matter? Because these discoveries touch our deepest questions. Where did we come from? Are we alone? Every time we point a telescope like Webb at the sky, we seek to understand our own origins. The technology developed for space exploration drives innovation here on Earth. These discoveries give us perspective, reminding us we share a fragile planet in a vast universe. They inspire us to look beyond our differences and recognize our shared identity as Earthlings. Exploration is in our DNA. We've always been driven to see what lies beyond the horizon. The cosmos is our final frontier. Discoveries like Webb's observation of 3I/Atlas feed our curiosity and sense of wonder. They remind us we are part of something magnificent, and the journey of discovery has only just begun.